So I wanted to make a video about my torque plates. The finished product is seen here. These torque plates are very strong. They are 1/4 inch 303 stainless steel. It's definitely strong enough because my Cromotor, these are bare Cromotor axles, can put out up to 150 Newton meters, and we don't want to crack the frame. So this here, if you see that cross section of the axle, it's a 5/8 inch circle with 10.8 millimeter axle flats, and this is a piece of cherry wood that I've had made, which has the exact same dimensions. This right here is standard bicycle dropouts, which is for a 1/2 inch axle with 10 millimeter axle flats. And because the Cromotor axles are a little larger, this is a derailleur hanger that I have filed out to fit over the wider Cromotor axle. So the plan here is to get these from the machine shop. I have these made at the machine shop. They cost between $25 and $80 each. It's a 1/4 inch 303 stainless. It's really hard. I have the machinist make my D-hole, and that D-hole is a 5/8 inch circle with 10.8 millimeter axle flats there. And then my machinist, I tell him to do that as a maximum, so that when I get these torque plates, I need to file them out. So when I get these back from the machine shop, that D-hole is purposely made too small, and the motor axle will not fit through there. I have to hand file that so that it results in being a really tight fit. This has been hand filed, and so it's a really tight fit. The axle goes through there, tight fit. There you can see the torque plate bolted to the frame. The torque plate is that rectangular piece of metal between the axle nut and the axle. Here's a view of the torque plate in place. Here's another view. Here's where the torque plate went. You can see the dropout, the axle sticking through. That's a Cromotor axle. That dropout has been filed out to make it a little larger, and the 2 mounting holes on the frame are used to mount the torque plate. So these 2 torque plates are completely identical. This one has not been to the powder coater yet, and you see it fits over, and it fits. This one did fit, but then when I sent it to the powder coater, the 5 to 8 mils of powder coating has made it so that it's too tight. So I'm going to have to file that out to fit over the axle. So I use this hand tool to file it down, and just a little bit of filing, and now it goes on very tightly. This is the sort of hand files that I use for this job. So now this has been filed down and it fits over there really tightly. Very tight fits, and I'm going to put on the bolts. Here's my old bolts, but I got some powder coated bolts so it'll be more attractive. So there it is, done, installed. Here's the other side before I put on the powder coated torque plate. You see the torque plate there is mounted with 2 bolts to the frame and with 1 bolt to the frame and the disc caliper mount. And here's the torque plate installed. That will prevent the frame from getting cracked. So what I've done is, on all my e-bikes, they have the same Cromotor, the same axle, so all the parts are interchangeable. So I have spare axles lying around. And before I got a hold of the spare axles, which were ordered from Zelena Vozilla directly, I made this out of cherry wood, which is this is a 5/8 inch diameter circle flattened down to 10.8 millimeters axle flats. Here again you see a 5/8 inch diameter circle with 10.8 millimeter flats. So got these axles lying around, and when I'm going to make some new frames, I buy these dropouts from Paragon Machine Works in Richmond, California. They're chromoly steel. I get these dropouts, and then I take a torque plate that's known to work. This torque plate has been run on a bike, and so it's been tested. And then I bolt it up to a bare dropout, and you can see in there the area that I need to file out. So I've gone in there with a marking pen and very aggressively marked where it needs to be filed out. So now I can use my hand files and I can file it out for the larger Cromotor axle. So it'll be a nice fit, because these dropouts are just for standard bicycle axles and the Cromotor axle doesn't fit in there. Now, if you have a torque plate that's known to work, like I've run this on a bike and I know it fits onto my bike, and I have this for another bike and I need to know where to draw all the holes, obviously I can just take and go like this and tape it together and just put it in the drill press like that. But if I don't have this, if you're just starting out and all you have is this and you need to know where to draw the holes, if you have the dropout handy, you can go like this, depending on how you're going to orient the plate, and orient your torque plate like this. And you would want to do this after you file that out. I should take the time to file that out, but I'm not going to do that. But you would file that out and then make sure that your axle is fitting in there tightly, and then you could mark the holes there to see where to drill your holes. And I would drill, personally, I would drill pilot holes with the axle in there. And of course all this is dependent if you have, you know, an extra axle lying around. But like I say, all my bikes, I run the same exact parts. All the parts are interchangeable. And this axle costs $50 from Zelena Vozilla. And you know, $50 isn't bad, because later on down the line I might strip some threads or break an axle or who knows what. So there's the torque plate, and you could see where to draw the holes. And then I make stuff too tight and then I hand fit it to the bike, and it takes a long time, but it makes for a really tight fit on the bike. I mean, when it's on the bike, I'm having to, you know, drill clearance holes because it's hard to get it on the bike. It just makes for just a really tight fit. Here's the setup without torque plates, which I do not recommend. I ran this setup and I cracked my dropouts after about 50 miles. I thought it was okay to run my bike while the torque plates were at the powder coater. So I turned down the power in the cycle analyst. I limited the current to 25 amps, but I got a little power surge, less than 0.2 of a second. I got a little power surge of 80 amps for a short time, and it cracked the frame open on both sides. And so I had to do TIG stainless repair, re-powder coat the whole frame. Very expensive, very time consuming. So now I never run bikes without torque plates, or if you're someone else, torque arms. My torque plates are 1/4 inch stainless steel, and I haven't had any failures yet. One additional benefit of this torque plate design is if the axle nuts were to loosen and fall off, you'd have the torque plate bolted to the frame in such a manner so as to hold the axle on so that your back wheel wouldn't fall off. Here's a picture of the torque plate fully installed, bolted down tightly. So here's the finished torque plate, which is back from the powder coater, installed on my bike. It has 2 anchors that are clamping the torque plate to the frame, and then has an additional bolt which is attached to the frame and the brake caliper mount, and then the axle nut. So it's there ready to prevent my axle from damaging my frame.